In this project, we will talk about electrical switch. In our daily life, we are using the manual switch to turn on and turn off our lamp, or fan, etc. If we want to automate the switching action, we need an additional electronic circuit, an electronic control switch. For us, we can combine an Arduino, some sensors, a program, and an electronic control switch. There are two types of electronic control switch, mechanical relay and solid-state relay. Let's just call them Relay and SSR. A relay using magnetic coil to trigger the switch action. SSR is an integrated circuit that acts like a mechanical relay. It allows us to control the high voltage AC loads from lower voltage DC control circuitry. SSR has several advantages over mechanical relays. It can be switched by a much lower voltage and lower current than most mechanical relays. Since SSR doesn't have moving contacts, it can be switched much faster, and for much longer periods without wearing out. Here is a 24-volt mechanical relay in action. It needs higher voltage and current. Since it is a mechanical device, it can switch around 30 times plus per second. For SSR, it can switch 1000 times per second easy, and can be much faster with the high-end SSR. For Arduino, here are two common mechanical relay and SSR which can operate with 5 volt. Let's see how a relay and an SSR to replace a manual switch on an electronic circuit. This is a very simple circuit, a battery and a switch which connect to a LED and a laser. When we turn on the switch, a circuit is formed, the LED and laser will be turned on. For our project, we keep the switch in the closed state, on all the time, and add a relay and an SSR as an additional switch for the LED and the laser. We don't need additional library. In our project, we will connect a relay to pin 6 and a SSR to pin 5. In the setup function, we enable these digital pins for output and initialize them in low state. In the loop function, we will turn these pins high and low. It will then turn the relay and the SSR on and off. In general, we need to add a delay function for these devices to react. From my experience, at least delay 250 milliseconds for the devices. In this example, we added 3000 milliseconds delay function which is 3 seconds delay. Here is our project in action. We can see the relay and the SSR modules are alternatively turning on and off. The relay is connecting to LED, which works fine. And, the SSR is connecting to the laser. Hold on. Why the laser is on and doesn't turn off? Remember, we said SSR allows us to control high voltage AC loads. In our low voltage project, SSR is only a high resistance device. Without the high voltage loading, this circuit won't work. Since this laser can operate in lower voltage and current, so it turns on all the time. For the following setup, we will connect SSR to AC 110 volt and a table lamp. It is only for demoing SSR in action. We don't recommend you to set this up yourselves unless some experienced people can help you out. This is the ending. Can the mechanical relay work on high voltage AC circuit? Yes, we may need to buy a bigger mechanical relay, but the bigger relay cannot be driven by 5 volt. In the real project, we will use a small 5 volt relay to cascade the control to the bigger relay. However, why we won't directly use SSR instead? Yes, we need to use the higher voltage and higher current SSR. In some case, the designer may use a small SSR to cascade the control to the more power SSR. This is called decoupling.